I will start with the examples on free damped vibrations. A gun barrel weighing 600 kg has a recoil spring stiffness of 345 Newton per mm. If the barrel recoils 1 meter on firing, we have to find out what will be the initial recoil velocity of the gun and the critical damping coefficient. So we'll write down the data first. So mass is given as 600 kg. Stiffness is given as 345 Newton per mm. So 1 mm is 10 raised to minus 3 meter. So this 1 upon 10 raised to minus 3, it will come in the numerator. Reciprocal will be 10 raised to 3. So we have converted Newton per mm into Newton per meter. So it is 345 into 10 raised to 3 or multiply by 10 raised to 3 Newton per meter. Required distance is given as 1 meter, so displacement is 1 meter. We have to find out velocity and cc, that is critical damping coefficient. So velocity is nothing but x dot. So we can say that according to the law of conservation of energy, strain energy stored in a spring is equal to initial kinetic energy of the gun barrel. So strain energy, as we have already derived, it is 1 half kx square, and kinetic energy is 1 half mv square. 1 half will get cancelled from both the sides. Substitute the value of k, that is 345 into 10 raised to 3. X is 1 and square of that. Mass is 600 and v square. So you'll get the value of v. So 345 multiplied by 10 raised to 3 multiplied by 1 divided by 600 will give you the value of v square, and take square root of that particular term. So you'll get value of v as 23.979 meter per second. So again see the calculations. 345 multiplied by 10 raised to 3 multiplied by 1 whole divided by 600 will give you the value of v square, and then take the square root of that particular value. So you'll get the value of v as 23.979 meter per second. Now for linear system, critical damping coefficient is given as 2 square root of k multiplied by m. Substitute the values. Value of k is 345 into 10 raised to 3 and mass is 600. So Cc will be equal to 28.774 multiplied by 10 raised to 3 Newton second per meter. Let us see another example. An underdamped shock absorber is to be designed for a motorcycle of mass 200 kg such that during a road bump the damp period of vibration is limited to 2 seconds and amplitude of vibration should be reduced to 1 upon 16th in 1 second. So this is the important part. Find the stiffness K and damping coefficient of the absorber, shock absorber. So mass of the motorcycle is given as 200 kg. Now for damped period of vibration, so Td is given as 2 seconds. Then from this Td we can easily calculate the value of omega t, that is 2 pi ft. Frequency is 1 upon time period. So substitute the value. So 2 multiplied by pi multiplied by 1 upon 2. So that will give you the value as 3.1415 radian per second. So this is the angular frequency or angular velocity. Now it is given that in one cycle there is a reduction of 1 upon 16th of the amplitude. So x2, that is the final amplitude, is 1 upon 16 times the initial amplitude. So we can say that cross multiply by this. So 16 will take on this side, x2 on this side. So x1 upon x2 is 16. Now using this we can easily calculate the logarithmic decrement. So delta is equal to ln of x1 upon x2. Substitute the value of x1 upon x2, that is nothing but 16. So we'll get value of delta as 2.773. Also zeta is equal to, that is damping factor, is equal to delta divided by square root of 4 pi square plus delta square. Value of delta, that is logarithmic decrement, is 2.773. Square root of 4 pi square plus 2.773 and square of that. Solving this, we'll get zeta is equal to 0.404. Now we know that damped angular frequency omega d is equal to omega n square root of 1 minus zeta square. So omega n will be equal to this term which is in multiplication will go on this side in the division. So it is omega d divided by square root of 1 minus zeta square. Substitute all the values. Omega d we have calculated, zeta we have calculated, and check whether you are getting this answer or not. Now omega n is equal to square root of k by n. Squaring both the sides will, this particular square root will go. So it is omega n square is equal to k by m. Cross multiply by this m to this omega n square, so that you will get k is equal to m omega n square. Substitute the value of m and omega n. Omega n is 3.434, which we just now we have calculated. So value of k comes out to be 2358.471 Newton per meter. Now damping coefficient we have to find out. So zeta is equal to c upon cc. Cc is 2 root km. Cross multiply by this term. So c will be equal to zeta multiplied by 2 root km. So substitute the values. Zeta we know, square root of k and m, those values are also known to us. Just substitute those values and check whether you are getting the value of damping coefficient as 554.934 Newton second per meter.